What's 10 times more powerful than the Hiroshima bomb and happens 45,000 times a day? It's the common thunderstorm.
Because of your overwhelming response, the Weather Channel will once again present Clash of Seasons. We'll be on the air live, answering your phone-in questions, offering safety tips, and more. We bring this information to you because we believe it's vital.
Clash of Seasons, coming up next on the Weather Channel. The 36-hour forecast. Special regional information. Stay tuned for the latest weather information here on the Weather Channel.
The following is a special presentation of the Weather Channel.
Spring down there. Life full of promise. But high above, the icy breath of winter lingers, waiting for spring's warmth to rise. And when they meet, winter and spring,
Hello, I'm Dennis Smith. Welcome to A Clash of Seasons, Take 2. Your response to our program Easter Sunday was so enthusiastic, we decided to do it again. Thunderstorms can be killers. Lightning, flash floods, tornadoes, wind shear. They're all dangerous to life and property. So we feel repeating this program is important. We have some distinguished guests with us. Beside me is Dr. Robert Maddox, Director of the National Severe Storms Laboratory in Norman, Oklahoma. Glad you could join us today.
Thank you, Dennis.
Got a lot of questions on the line already ready for you.
Okay.
Meanwhile, later in the program, Captain Bill Melvin, a pilot for Delta Airlines, will be here to answer your questions about the dangers of flying in thunderstorms. We'll give you the phone numbers to call in a few minutes, but first, let's look at part one of our videotape presentation. These features were produced with the help of the State University of New York at Brockport and the National Science Foundation. Most of the time when we think of thunderstorms and tornadoes, we think of the Wizard of Oz and Tornado Alley. But actually, thunderstorms can hit anywhere at any time. An average of 45,000 thunderstorms a day form on the planet Earth, and in each one may lurk energies 10 times that in the bomb that destroyed Nagasaki. Thunderstorms need a number of elements to develop. Included are moisture, uplift, and strong upper-level winds. Uplift is created when the sun heats the Earth's surface, when wind hits a mountainside, or when cold and warm air masses collide. When the surface air rises, it cools, so moisture in the air condenses and forms clouds. This is the cumulus stage. At this stage, the storm is made entirely of updrafts. If there is a strong wind aloft, like a jet stream above the cumulus cloud, air is removed from the cloud at the top, and more warm, moist air is drawn in at lower levels, adding energy to the storm. Finally, the water droplets and ice crystals that make up the clouds become too massive and heavy for the updraft to support. They begin to fall. As they fall, they drag the air down with them, creating a downdraft. Now, several updrafts and downdrafts can exist in a single thunderstorm. At this point, the thunderstorm is mature. Heavy rains fall in the downdraft. Strong winds fan out at the bottom of the storm in what's called a gust front. There's lightning, maybe hail, and sometimes, but not often, the thunderstorm's most frightening product, tornadoes. Finally, the updraft weakens, the downdraft takes over, and the storm collapses. This thunderstorm's life is over. But meanwhile, this storm's gust front may have aided in the development of more thunderstorms. The cold downdraft undercuts warm, moist surface air, providing new uplift for another storm. When this kind of chain reaction occurs, the developing storms merge to form clusters or lines. As this series of satellite photos show, those lines of thunderstorms can be hundreds of miles long and race across a landscape at up to 60 miles an hour.
One other way that we get organization, and we get it in the spring and summer months of the year, is we get complexes of mini thunderstorms, maybe 100 or more, that all form together into this thing called a mesoscale convective complex. And it grows so large that it has a mind of its own. It's hard to forecast, and it changes the weather, for instance, for the next day. It's so big and has such long-lasting effects that once created, it may last 2 or 3 days and affect several states, maybe go all the way from the central part of the country to the East Coast.
But a thunderstorm doesn't have to be large to be dangerous. A look at the ways a thunderstorm can hurt you in Part 2. Meanwhile, call these numbers with your questions. We'll be back after this.
You never really think about the little things you can do to save a lot. Look at something as simple as these shades. In the winter, you should leave them open to allow the sun to warm your room. But in the summer, you should keep them closed so that your air conditioner needn't compete with the sun's warming effects. You'd be surprised how tips like this can save you money. No, I'm not an energy expert. I learned about this and more from my home energy savings video. It's full of practical advice about insulating your home, choosing an energy-saving furnace or air conditioner, plus necessary maintenance information. By following the valuable tips in the home energy savings video, you can save hundreds of dollars off your energy bill. With today's rising household costs, you need the home energy savings program.
Home energy savings video, just $12.95. Call 1-800-245-9898 or send check or money order to Handyman Video Guides.
The 36-hour forecast. The 5-day forecast. Stay tuned for more weather updates here on the Weather Channel.
We're continuing with Clash of Seasons, Dr. Maddox, mesoscale convective complex. What a mouthful, but Don Burgess was referring to it in the videotape segment we had at the first there. I believe you were one of the first people to actually observe this phenomena, and you've been studying it a while. You want to define it a little bit better for us?
Surely, Dennis. What we mean when we say mesoscale is just like Don was saying, we're talking about tens or literally hundreds of individual thunderstorms all working together and merging and consolidating into what becomes a long-lived mesoscale weather system about the size of a Midwestern state like Kansas. And the mesoscale, once they start working together, kind of also means that they can last much longer than ordinary thunderstorms.
So it's like a complex or a group of thunderstorms all working together instead of just one.
Just exactly.
So instead of maybe having the experience of one thunderstorm and passing off, it's maybe a group of thunderstorms that may last for quite a few hours.
Quite a few hours. Sometimes in the Midwest it can literally rain all night, and also lightning and thunder.
Merciful heavens. Let's talk about some phone calls now. From Pittsburgh, Pennsylvania, we have a caller. Go ahead, please.
Yes. Is there any chance of people being killed in a car if lightning ever happens to hit on a hood while they're traveling through an electrical storm?
Go ahead.
I'll go ahead and try that, Dennis. An automobile is usually very well insulated and is quite a safe place to be during a lightning storm.
The only incidents I've heard of where there may be someone that was injured or killed by lightning was when they were trying to get out of the car during an electrical storm, where they were no longer having that protection of the grounding from the tires or something like that.
Yeah, either that or in a pickup. The pickup's not protected.
Right. Another question, this one coming from Southgate, Michigan. Go ahead, please, with your question.
Yes, I'd like to know if thunderstorms, the rains, and the storm itself can be just as intense in the rains and deadly as in Florida.
I believe the question was in reference to different parts of the country and intensity of the thunderstorms.
Okay, if I understood the question, Dennis, I think the answer is clearly yes. The rain rates that thunderstorms produce can be just as heavy in Michigan or even on occasion eastern Montana as the summertime thunderstorms in Florida.
Right, and then sometimes they can put out as much as 2 to 3 inches in just an hour period, too.
That's right, 2 to 4 inches of rain in an hour, and we're in trouble then when we get 3 or 4 storms like that back to back.
Because flash flooding can occur
That's
rapidly then. Our next caller is coming from Seattle, Washington. Please go ahead. You're on the air.
What was the most dangerous storm recorded, and what happened?
As far as thunderstorms, it'd be, for me, hard to nail down. There's been so many that have been so intense, and outbreaks of tornadoes, like in April 3rd of 1974, as we'll describe a little bit later on in the video. But naming one single thunderstorm, have any come to mind right off the bat?
The one that comes to mind, Dennis, is what we call the tri-state tornado back in the 1920s, where the tornado crossed from Missouri all the way into Indiana and killed over 600 people.
That was a major storm. It may surprise you to hear that Florida gets the most thunderstorms in the United States, an average of about 60 a year. The Tornado Alley states only get about 40. Theirs tend to be more severe, however. It's the jet stream that determines where severe thunderstorms form. So in early spring, the southern states get most of the action. In April through June, it's in the plains and Ohio Valley. June through August, the northern plains and Great Lakes. Time of day? Any time is possible, but daytime heating makes the afternoon and evening most likely. Thunderstorms have several nasty tricks up their sleeves. Lightning, tornadoes, microbursts, hail, and the most obvious is heavy rainfall. The updrafts within a developing thunderstorm carry water droplets tens of thousands of feet. Sometimes as much as 500,000 tons of water can accumulate in a thundercloud. When those tons of water plummet towards the earth at speeds of 60 miles an hour, is it any wonder flash floods may be the result? In July of 1976, a 19-foot wall of water roared down the Big Thompson Canyon in Colorado, the result of heavy thunderstorms in the mountains above. Thousands of campers were in the canyon that night. 139 were killed. Urban flash floods are a growing problem. This one in Kansas City in 1984. If you're ever threatened by a flash flood, get to high ground quickly. Stay away from stream beds and never ford a stream. And if your car is stalled in a flooded area, abandon it if you think you can make it through the flood safely. Lightning is basically a massive discharge of static electricity. You've experienced static electricity. Have you ever done this and then this? In a storm, strong updrafts and downdrafts, positive electrical charges accumulate at the top and negative charges at the base of the thunderstorm. The negative charges in the base induce positive charges on the ground below and for several miles around the storm. Finally, the accumulation of charge becomes so great, the air between can no longer insulate them from each other, and each lightning bolt can build up to several 100 million volts of electricity. The heat of a single lightning flash can be 5 times the temperature of the sun's surface. And And where does thunder come in? A lightning bolt heats the air to 50,000 degrees Fahrenheit. Thunder is the sound of the air in the lightning channel expanding under that tremendous heat. People are rarely killed by hail, but as the man behind the camera on these scenes can attest, picking smart. And it's serious business to a farmer. Hail destroys $1 billion a year in crops in the United States alone. You know what it can do to your house or your car. The life of a hailstone begins as a tiny ice particle in the cold upper reaches of a storm cloud. The updrafts and the downdrafts of the thunderstorm take it on a wild roller coaster ride, down into the warmer air to pick up water droplets, then back up into the colder temperatures, then down again. The stronger the updraft, the longer the ride, and the larger the hailstone. Finally, the stone gets too heavy for the updraft, and the mature hailstone races to the earth. You can tell how long the roller coaster ride lasted by cutting open the hailstone. Each ring of ice represents another trip up and down the thunderstorm. This is the largest hailstone ever reported. It fell in Coffeyville, Kansas on September 3rd, 1970. It weighed 1 2/3 pounds. Now, most hailstones range from only the size of a pea to a grapefruit, but even so, they can still make quite a splash. In our next segment, the terrifying power of tornadoes.
This is the weather. Sunshine and blue skies today, but tomorrow could bring clouds, rain, wind, or even dangerous conditions. Who knows what tomorrow will bring? The Weather Channel knows. Inside, 65 meteorologists are gathering data, analyzing conditions, and preparing forecasts for your town, your state, the nation, the world. Tune to the Weather Channel anytime, day or night, weekdays or on the weekend, and get exactly what you tune us in for. Weather information. And it's weather information you can use. If you travel every day or once a year, the Weather Channel is here to help you know what you're heading for. Skiers, gardeners, school kids, sun worshipers, you'll all find the special forecast you need on the Weather Channel. When severe weather threatens your area, you'll know immediately, and you'll always find the forecast that's only for your town. Sometime today, you may be out in the weather. Anytime today, you can tune in the Weather Channel. They know what tomorrow will bring.
Stay tuned for the Days In 5-Day Business Planner, keeping track of storm systems, hazardous weather, and poor road conditions that may affect your business travel. The Days In 5-Day Business Planner coming up in just a few minutes, right here on the Weather Channel, only on cable.
The 36-hour forecast. Day forecast. Stay tuned for more weather updates here on the Weather Channel.
Thunderstorms don't spawn tornadoes often, but when they do, they are dangerous. From a distance, beautiful in their own way. This next segment has some of the most spectacular tornado footage I've ever seen.
See those papers flung? Dude, that is a tornado. Look at all the papers over there. That's a tornado, yeah, leaves. Yeah, but look, it's picking it up. That's fantastic.
This is spectacular. This is spectacular. We have debris thousands of feet in the air. There are flash fires on all the high tension wires. We're about 3/4 of a mile from the actual touchdown at this time. This is really spectacular.
The experience is always the same when a tornado does its death dance right before your eyes. It puts the meaning back into the word awesome. Tornadoes average about 140 yards in diameter, but some are a mile wide. There may be several mini tornadoes around the main funnel, like a chorus line of destruction. Maximum wind speeds within a tornado may be up to 300 miles per hour. Some hardly move at all. Some race across the land at 75 miles per hour. They last about 10 minutes on average. But in 1917, one stayed on the ground for over 7 hours and destroyed everything in its path for nearly 300 miles. There's already a lot of violence in a thunderstorm before a tornado forms. Updrafts up to 100 miles per hour created by moist, rising air. Strong downdrafts from the drag of falling rain, hail, or snow. Add rotation to the updraft, and a tornado may form. The rotation may be provided by winds feeding into the thunderstorm from different directions. Then, like a spinning skater, pulling in his arms, the rotation becomes tighter and tighter and faster and faster.
These tornadoes extend high up in the clouds. A few of the very strong tornadoes extend up to the top of the cloud, and a satellite looking down at them might even pick out the swirl in the cloud that's visible in the overshooting area of the tall towers. So we can have a rotation, a tornado, a strong vortex that's as much as 50 or 60,000 feet tall in the extreme.
Tornadoes can occur on nearly every continent, but as you can see, the United States gets the most by far. It's caused by our unique geography: cold air masses from Canada, dry air down the slopes of the Rockies, and warm, moist air from ocean surfaces. About 700 tornadoes a year are reported in the United States. Like apple pie and the 4th of July, tornadoes are typically American. Once in a while, those geographic conditions combine with a huge unstable mass of air. The result? A terrible swarm of tornadoes sweeping across state after state. April 3rd, 1974 was one of those times. In the space of 12 hours, 125 tornadoes struck in 11 different states. The worst hit? Xenia, Ohio, Brandenburg, Kentucky, Monticello, Indiana, and Gwinn, Alabama. By midnight, a total of 303 people were dead, 5,400 injured. This tornado hit Minneapolis in 1986. People watched it live on TV as it was happening. They saw what a relatively small tornado can do. Those are whole trees being thrown into the air. The Vegeta-Pearson scale of damage rates tornado strength from F1 to F5. This was only an F2, but it did over $500,000 in property damage in the 30 minutes it was on the ground. But warnings were issued and no one was injured. Deaths in tornadoes occur when tornadoes strike without warning. However, here in Wichita Falls, Texas on April 10, 1979, the warnings were issued. Sykes Shopping Center was right in the path of the tornado. The shoppers inside knew the tornado was approaching, but tragically didn't know what to do about it. Panic ruled. Shoppers tried to run to their cars to escape the storm. They were killed in the parking lot as automobiles were tossed like toothpicks. In all, 44 people died that evening in Wichita Falls, most of them at the shopping center. It's always safest when a tornado approaches to stay indoors. Get into the basement or an interior room like a closet or bathroom. Stay away from glass and cover yourself with a mattress if you can. Tornadoes are killers and no one is immune. Those are important rules to remember when a tornado strikes. We have some more viewers on the telephone lines right now. This one coming from Long Island, New York. Go ahead, Long Island.
To know if the chances of a tornado touching down in eastern Long Island, what are the chances?
Pretty slim as far as I know, all the statistics.
That's right, Dennis. The tornadoes are most frequently in the more stormy central part of the country.
Right.
It's certainly not out of the question. You always have to stay on the alert. Tornadoes in New England on rare occasion have been killers.
It seems like the one that would most likely prompt in that area of the country would be maybe associated with a hurricane, some tornadoes kicking off of a hurricane and maybe moving up the East Coast.
Most hurricanes, as they come ashore, do produce numbers of small tornadoes, yes.
But we usually think of like Tornado Alley, the midsection of the country, because of all the ingredients coming together in that part of the year. Another caller from Phoenix City, Alabama. Go ahead, please, with your question. Phoenix City, I would like to hear your question. What do you got for us?
Is thunderstorms at the thunderheads ever been recorded up to 70,000 feet or higher? Have they ever reached that high?
The question was in reference to the height of thunderstorms if they're up to 70,000 feet. I think I remember even the Stillwater, Oklahoma storm back several years ago getting up to around 72, 73,000 feet, so they can penetrate that far into the atmosphere.
Definitely. With radar, we frequently measure 55 to up to occasionally as high as 70,000 feet for the tops of the storms.
So they can get well on up there. Portland, Oregon, we're going to the northwest to hear from your call. Go ahead, please.
Yes, sir. My question is this. I would like to know, how will ozone depletion in the atmosphere modify thunderstorm development?
Oh, boy.
Boy, that is some question, Dennis. There's not much I can say about it except that the real fears deal with climate. And if climate changes, perhaps the conditions that lead to storms will change also. But it's there's too many linkages in there for us to really address.
There's a lot of variables when you get down to what actually helps build in the thunderstorms and eventually the tornadoes and some severe thunderstorms. And I'm sure research will be done in the future to determine exactly how much the difference of the ozone in the Earth's atmosphere will change that.
Yes, in major programs.
In fact, we're going to be talking about in global crisis. That's coming up August 28th. We're going to be talking about the ozone layer and some of the facets around the entire world and how they're affecting climate. That's coming up August 28th. So our caller from Portland, Oregon, you can be looking forward to that. Essex, Michigan, we'd like to hear from you. What's your question, please? Okay, we'll get back to him a little bit later then. We apparently have a little trouble there. Dr. Maddox will be back to answer some more of your questions a little bit later. In our next segment, Captain Bill Melvin will be with us to talk about wind shear. You can call now with questions for Captain Melvin. Meanwhile, we'll take a break, then we'll show you what it's like to try to land an airliner in a thunderstorm's downburst.
Yeah.
Hi, Steve.
Susan? Susan?
Dining alone.
Oh, yeah, making a little pasta salad.
I love pasta salad.
You do? Well, I got tomatoes.
Yeah.
I got onions. I got milk. Oh, no, great. No Miracle Whip.
Really?
Good, Susan. Susan?
A salad just isn't a salad without the tangy zip of Miracle Whip salad dressing.
Ring. Come on, Ring.
The 36-hour forecast. The 5-day forecast. Stay tuned for more weather updates here on the Weather Channel.
Welcome back to Clash of Seasons. We'll be answering your questions about thunderstorms and aviation shortly. Our next tape segment was shot mainly at FAA headquarters in Oklahoma City. And while we were there, the pilot inspectors treated us to quite an eye-opening experience.
Ride slow.
We're taking a ride in a computerized flight simulator. At the controls, 2 pilot safety inspectors from the Federal Aviation Administration. This is what it's like landing an airliner through a thunderstorm's downburst.
You want to ride through that, cowboy?
We made it, but just barely. On our second try, we weren't so lucky. Wind shear's been around, well, as long as there's been weather, but it wasn't discovered until we started trying to fly through it. See, an airplane can only fly with the action of the air passing over and under the wing. When the wind shear abruptly changes the speed and direction of that air, it can cause havoc on the plane's ability to fly. Dangerous wind shear at ground levels is the result of a sudden rush of air crashing directly into the ground. It's so strong a downdraft, it's called a downburst. The violence of a downburst is sometimes so strong, the damage it does can look like a tornado's. In fact, many people swear they were hit by a tornado when it was really a downburst they had experienced. But from the air, the difference is easier to distinguish. These pictures by Theodore Fujita of the University of Chicago show typical downburst damage patterns, what Fujita calls a starburst pattern. Tornadoes create more spiral trails. The wind that flattened these trees seems to have come from nowhere. In reality, it came from directly overhead. When the downburst hits the ground, it spreads out in all directions, like spilled water hitting a table, and that's where the wind shear comes in. As an airplane enters the downburst at low levels, say when it's landing, it first hits strong headwinds. That increases its airspeed, and as a result, its lift. The pilot points the nose down to compensate. Then the plane crosses this line and encounters a tailwind. That decreases the speed of the air across the wing, the plane loses lift and begins to fall. If all this comes as a surprise to the pilot, the likely result is a crash. Dr. Kelvin Drogemeyer is studying downburst. He's created graphic downburst simulations on a supercomputer.
So as the rain falls, what you're seeing here, the blues and the greens and the reds, are the cold air. And as the air cools, it falls toward the ground and it spreads out in this extremely thin layer along the ground. The depth of this layer is only, say, on the order of a few hundred meters deep. And that's what makes the microburst particularly dangerous for aircraft, because it's not until they get close enough to the ground, close to landing, that they actually encounter that shear layer.
Where would be the most dangerous spot at any one time during the whole loop for a plane to be?
Probably,
is it when it's on its farthest reach there?
Well, actually, in terms of the most dangerous place would probably be right under here, because that's where the strongest downdraft is.
And that's almost straight down on top of them.
Right. And in fact, as the plane is flying through here, not only is it encountering a strong downdraft, but it's also encountering a strong tailwind. So if it's flying something on a trajectory like this, it's in a downdraft, it's also in a tailwind, and the lift of an aircraft goes as a velocity squared. So when there's a small change of velocity, it gets amplified by itself again, which really creates a loss in lift. And when the pilot is going through that, he has to take very drastic action to try and correct it.
Since the risk of wind shear is greatest near the ground, the FAA now recommends the pilot hit the throttle and try to fly up and away from the wind shear and the ground as quickly as possible. Airlines and the FAA are training pilots to escape wind shear.
Wind shear, max power.
But pilots must recognize wind shear when they encounter it in order to take corrective action.
Many of us have gotten into situations where we'd be, for instance, shooting an approach that's rough, it's turbulent. As passengers, we've all ridden in aircraft where the approach was rather rough and that sort of thing. But I think one of the things there is recognition of just how rough is acceptable and how far out of tolerances one would allow one to get. And I think we're judging nowadays that not very far. We try to get out of those situations. First of all, not get into them in the first place, and try to get out of them if we find ourselves there.
If a pilot can't get the plane out of this situation, this can be the result. This L-1011 crashed in Dallas in 1985. 134 aboard the plane died, victims of wind shear. 2 major crashes in 1984 were also caused by wind shear. As the death toll rises, it becomes clear. What's needed is more pilot training and more scientific research into forecasting wind shears. Those research efforts and more in Part 5.
But before we go on to Part 5, we want to hear your questions about wind shear. Here to help us answer those questions is Captain Bill Melvin. Captain Melvin flies for Delta Airlines. He's been involved in wind shear research for 20 years. He's chairman of the Airworthiness and Performance Committee with the Airline Pilots Association and is currently working with Rice University on a wind shear project. Glad you could join us today.
Thank you.
Concerning wind shear, have you personally ever flown through wind shear?
Well, pilots fly through wind shear all the time, and it accounts for a lot of hard landings and long landings and things like that. The microburst type wind shear that can be a killer, though, is very, very rare.
You've never flown through any
No,
of that?
I haven't encountered any microburst.
How about on the simulator, though? You've had some
I've had a lot of simulator experiences with wind shear and microburst.
Briefly, what would a pilot do if all of a sudden he encountered a wind shear, and what would he respond to? How would he, what would he do with the controls in order to get out of it?
Well, there's a considerable difference of opinion on that, and for a number of years they taught pilots to fly at the maximum angle of attack. We call it the stick shaker that simulates a stall. That's definitely wrong and one of the worst things you can do. That has been proven theoretically by the studies at Rice University, which were funded by NASA Langley. Now there still is some, I wouldn't say disagreement, but there's still an ongoing research in this field. The optimal trajectory studies show the best way to possibly fly through a given wind shear. It's a little bit different than what some of the present guidelines are, and we hope to change some of the guidelines based on that.
How would a pilot detect by his instruments, by the feel of the plane? How does he know that he's involved in a microburst wind shear?
Well, he knows because the performance of the aircraft is telling him that. That is, the airplane starts sinking, he starts losing airspeed, he's going below the glide slope, and then he responds to that with thrust application in an attempt to get out.
Okay. We'll have some more questions about wind shear coming up in just a few minutes. Captain Melvin will stay with us to answer more of your questions. The numbers again to call are 1-800-327-0945. And if you're calling from the state of Georgia, area code 404-434-9762. We'll be back after this.
We can track each year, beginning in June, about 100 disturbances that come all the way across the Atlantic. 1 in 10 of those develops into a tropical storm.
Hey, we have a current map ready? 155. So how are we going to do this?
Every hour we'll be on about 52 minutes after the hour, and that's going to be 24 hours a day.
The hurricane is on its way, and you are advised to evacuate.
And then once it does become a hurricane and is a threat to the United States, we increase our coverage a great deal.
36-hour forecast. Regional forecast. Special regional information. Stay tuned for the latest weather information here on the Weather Channel.
We're back with Clash of Seasons and Airline Captain Bill Melvin. We talked about briefly thunderstorm microbursts and the downburst that comes out of thunderstorms. You can have them in other parts of the atmosphere as well, can you not?
Well, that's true. They're rapidly developing convective clouds, convective cells, can generate microbursts before the convective cell becomes identified as a thunderstorm. That happens to be one of the most dangerous times. By the time you have an identifiable thunderstorm, there's little risk that a pilot will go close to it or into it, because he wouldn't deliberately do that. But the greatest risk occurs from rapidly developing convective cells that have not been identified as hazardous.
There's no reports of any precipitation off the radar, or there's no signs or other pilot reports that there's any problems in the area? Is that...
Well, what we think is there are unique conditions that cause the acceleration upward and downward. Dr. Fernando Caracena has described these conditions, and the cell can grow at 6,000 to 8,000 feet per minute. So in a matter of 3 or 4 minutes, it's grown from a 15,000 foot cell to a 40,000 foot cell. And then you can generate a microburst. After that, you may say, you know, there's a thunderstorm there. But it's that first shot that is probably the most dangerous and the least likely to be recognized.
And again, the way to recognize it is what you described earlier in the show, where they'll see the plane's performance is not where it should be. And
yeah, if you're there. In other words, we would like to not ever have a pilot encounter microburst. Avoidance is the best thing. However, there are occasions when a pilot will possibly be in one, and then the research at Rice, of course, is to try to find the best way to fly out of it, and possibly devise guidance schemes, instrumentation to aid the pilot.
Okay, we do have a question on the line from DeWitt, Michigan. Go ahead, please, with your question. Hello, DeWitt. You have a question for us out of Michigan? Apparently we're having a little problem getting that phone call in the air. Let me ask you about lightning and airplanes. Any danger?
Well, lightning's not a real hazard to an aircraft. A lot of aircraft been hit by lightning. There are a couple of cases in history where it destroyed aircraft, but transport category aircraft, by certification requirement, has to be immune to lightning. So, not that anyone would like to be hit by lightning, but it's not something that strikes fear in the heart of pilots. Okay. However, you wouldn't deliberately go where you thought you'd get hit by one.
Right. Another question, this one from Imperial, Missouri. Go ahead, please, with your question.
Yeah. What is the regular wind speed of wind shear?
Well, the wind shear is around us all the time. When you walk outside and you have a gusty wind or something different, that's really is wind shear on a small scale. The type that we're talking about that's a microburst generally be 30 or 40 knots across the base of a downdraft. Now, the larger ones will be 100 knots across the base, and the strongest one ever measured of a microburst was measured at Andrews Air Force Base, I believe in 1983. It missed President Reagan by 6 minutes, and it was 210 knots from one side to the other, from the center.
Okay, another question. We're back to DeWitt, Michigan. We're going to try you again. What do you got for us, DeWitt?
Hi, I was wondering, do these microbursts ever produce tornadoes, and what would happen to a person walking across the field if this happened?
Well, a microburst really isn't associated with a tornado. The same storm, if it becomes a giant storm, could do both. And maybe at the same time, I don't know. But frequently you see microbursts that destroy trailer parks. They destroy, cars have been blown off the road. There was in Alabama 2 or 3 years ago, there was an excursion boat blown over, and a lot of people drowned. You can tell the difference in a microburst from a tornado by the pattern that it creates on the ground. And this is what led Dr. Fujita to talk about microbursts to begin with, is that he was a tornado expert, and is. And in examining what was thought to be tornado damage, he discovered that there was evidence there of something that was not, in fact, a tornado. And that led to microburst.
More of a slam down pattern than a spiral pattern.
It spreads out in fan shape.
Right. Okay, thank you very much. We appreciate it. In fact, Captain Melvin, thank you so much for joining us today. We sure appreciate it. And Dr. Bob Maddox will be along with us from the National Severe Storms Laboratory in our next question and answer segment. And what's on the drawing board in thunderstorm forecasting? Well, we'll learn about some life-saving research after this.
Pacific's Your Guide to Building a Deck videotape, you can open your home to more living space and greater resale value. It's over 20 minutes of simple step-by-step instructions that give you the confidence to build it yourself. Your Guide to Building a Deck shares GP's years of experience as a building products industry leader. Call 1-800-358-3200 and get your tape for $19.95 plus $2 shipping and handling. You'll also get a 42-page deck booklet and a Stanley chalk line and level, all at no additional cost. So come on, order now and start enjoying your own deck.
Start taking those first steps towards lifelong memories. Let Georgia Pacific help you build great possibilities.
Order your videotape, booklet, and tools today. You can use Visa or MasterCard. Money back if not completely satisfied. Order now.
Stay tuned for the Days In 5-Day Business Planner, keeping track of storm systems, hazardous weather, and poor road conditions that may affect your business travel. The Days In 5-Day Business Planner coming up in just a few minutes, right here on the Weather Channel, only on cable.
The 36-hour forecast. regional forecast. Special regional information. Stay tuned for the latest weather information here on the Weather Channel.
There was a time when we didn't really predict severe weather. We just reacted to it. But because of years of research and the new understandings and technology that have come out of it, we're getting better and better. Thunderstorms carry an arsenal of dangerous weapons, and many of them can strike with little or no warning. Much has been learned about severe weather in just the last few years, but much is still unknown. We know what a thunderstorm can do, but when, where? The answers to these questions can rarely be predicted with accuracy. Any advances in tornado and thunderstorm forecasting will probably come from here, the National Severe Storms Laboratory in Norman, Oklahoma, NESSL as it's affectionately known. Now, it may not look terribly impressive to the casual observer, but to storm researchers, all roads lead to Norman. One of the most promising new tools to come from NSSL is Doppler radar. With Doppler, a trained forecaster can look inside a thunderstorm cloud and actually see a tornado forming as much as 25 minutes before it hits the ground.
A conventional radar sends out a signal, and just a fraction of the energy bounces off of precipitation. Raindrops, hailstones, comes back to a receiver, and it stops there. A Doppler radar, it starts with that same signal, bounces it off of the precipitation, but when it comes back, not only does it measure the amplitude of return power, but in addition, it measures a slight frequency shift that occurred when the energy bounced off the raindrops. And that frequency shift gives you the motion of the raindrops. Knowing that, we see then the rotation up inside the cloud.
But even with high-tech Doppler radar, someone in the field has to be there to prove that what the Doppler says is happening in the storm really is. Chase teams provide the eyewitness accounts, like this one headed by Howard Bluestein of Oklahoma University.
When we're there at the storm, we can say, yes, there is one, or no, there isn't one. Yes, there is large hail, or no, there isn't large hail. There may be small hail or no hail at all. Another very important purpose of the Severe Storm Intercept project, which is becoming more and more apparent in recent years, is that we're able to make direct meteorological measurements in the vicinity of severe thunderstorms and tornadoes. We're able to make measurements of pressure and temperature and wind in the vicinity of these storms. We're able to release weather balloons in the vicinity of these storms to learn more about what actually causes these storms to form in the first place.
Chase teams make those direct measurements with a device they call Toto.
Deploy Toto right here, Steve.
The idea is to leave Toto in what they hope will be the path of the tornado. They've been successful only a handful of times, but even so, Toto has revealed some important new information about tornadoes.
We have learned with Toto, for example, that the pressure drops in the vicinity of tornadoes, of some tornadoes, is not as large as had been expected earlier. We have also learned with the balloons that the depth of the relatively humid air right where the storms form is a lot greater than it is elsewhere.
The development of Doppler radar has led to more new forecasting tools. If you point Doppler radar vertically, you have wind profilers. They sample wind speed and direction at different heights almost continuously. Until recently, such measurements were taken only by weather balloons about every 6 hours. The wind profiler means better information, more information, and improved forecasts. LiDAR Doppler is another application of the same basic technology. LiDAR uses radiation frequencies close to that of visible light. It's used to see wind patterns in clear air, the kind of patterns that can be very dangerous for aircraft. With all this new information, thank goodness for computers. These computers, known as AWIPs, will soon be in every weather office in the country. They'll let forecasters see several layers of data on one screen and help make sense of the information explosion. Very fascinating. Dr. Maddox, you've had a lot to do with all that with the NSSL in the last several years, have you not?
Well, we at the lab certainly feel that we have. It's our mission to work closely with the National Weather Service to help prediction and warning.
A lot has been talked about Doppler radar. It's How's that coming along, and when will we expect those to be installed, and how will they be working when we get into them?
The installation of sophisticated Dopplers is going to start in about a year at Weather Service offices around the country. The first one will be at the Oklahoma City Forecast Office, but then the Weather Service will buy over 100 radars for weather warning purposes across the entire nation.
Looking forward to it. I'm sure it's going to help in the forecasting as far as severe thunderstorms and many facets of weather coming up in the future.
Definitely.
We've got a caller on the line, this one from Fort Smith, Arkansas. Go ahead with your question, please.
Yes, what is the range of the Doppler radar? How far can it penetrate?
The range of a Doppler is pretty much the same as the radars we have now. We can see precipitation and storms accurately out to a little over 200 miles. The new radars are going to have high resolution capabilities to map the wind field inside storms out to a little over 100 miles.
The detection of tornadoes seems to be a circulation associated with severe thunderstorms with tornadoes. What's the best accuracy? What's the farthest range that they've been able to detect that up to this point?
They've even been able to detect mesocyclones, i.e. the really intense thunderstorms, Dennis, out to over 200 miles.
Oh my gosh.
But the key is it's the very large and dangerous tornadoes you can see at the very large ranges.
Okay. Next question's coming from Dallas, Georgia. Go ahead, please, with your question.
Yes, I'm wondering, have you been able to pinpoint with this Doppler radar a tornado developing in a cloud in a specific area, let's say a square mile, and warn an area, 20, 30 minutes before the tornado is going to touch down in that particular isolated area?
That's pretty much precisely the reason that the Weather Service has been convinced to go to the new technology, Dennis. On occasions with strong storms, you can map the circulations in the middle levels of the storm 20 to 30 minutes before the actual intense tornado occurs. So yes, success like that has led to new technology.
Good. That's really helping out in our forecasting of that exact situation.
Yes.
Let's hear a call from East Liverpool, Ohio now, please. Go ahead.
Yes, what state would you say had the most tornadoes?
I didn't quite hear that
I
question.
didn't catch that one either.
What area or state has had the most tornadoes?
Okay. Tornadoes are most frequent in the Central Plains states of the United States, from western Iowa, Nebraska, southward into North Texas.
I guess it'd have to be your part of the country where NSSL is located at, around Oklahoma City, Norman, Oklahoma, because that's why you have it there.
That's a big part of the reason, yes. We're out in what's called Tornado Alley, where large storms frequently happen.
That's a good place to be to see them, right? Pensacola, what do you have a question for us today?
Good evening. My question is about tornadoes that spin off hurricanes. Do they follow a different travel pattern than regular tornadoes, and are they as dangerous?
I'd like to see what defined as a regular tornado, too, because they've been very erratic in the path of development and even the course that they take. But you want to expound a little bit on the hurricane situation?
Let me kind of back through that one.
Okay.
They're certainly as dangerous as whatever regular tornadoes are if they happen to hit your house or your mobile home. They are typically smaller and don't have lives nearly as long as large tornadoes with severe thunderstorms. They're certainly just as dangerous, and the only difference is they're occurring in the hurricane environment.
Right. Which is already a nasty place to be anyway, so be careful there. We'll take another break for your local forecast, and we'll be back with a wrap-up.
This is the weather. Sunshine and blue skies today, but tomorrow could bring clouds, rain, wind, or even dangerous conditions. Who knows what tomorrow will bring? The Weather Channel knows. Inside, 65 meteorologists are gathering data, analyzing conditions, and preparing forecasts for your town, your state, the nation, the world. Tune to the Weather Channel anytime, day or night, weekdays or on the weekend, and get exactly what you tune us in for. Weather information. And it's weather information you can use. If you travel every day or once a year, the Weather Channel is here to help you know what you're heading for. Skiers, gardeners, school kids, sun worshipers, you'll all find the special forecast you need on the Weather Channel. When severe weather threatens your area, you'll know immediately, and you'll always find the forecast that's only for your town. Sometime today, you may be out in the weather. Anytime today, you can tune in the Weather Channel. They know what tomorrow will bring. the 36-hour forecast. The 5-day forecast. Stay tuned for more weather updates here on the Weather Channel.
Dr. Maddox, we're very glad you could find the time to be with us today. We're not going to let you get off that easy, though. You got a seminar to conduct with our meteorologist tomorrow morning.
Well, I'm looking forward to it.
So are we. We'll see you bright and early for that. We've had a lot of requests for copies of the tape portions of this program. Tapes may be purchased through Dr. Ira Gear, the Everyday Weather Project, State University of New York at Brockport, New York. The proceeds for those sales go towards the creation of more educational materials. These educational materials will be of interest to your community, organization, or school. It's a videotape program and a newspaper designed to tell you how to react to protect your home and family during natural disasters. The Weather Channel and the American Red Cross have produced these programs, and they're available at no cost to your community or group. Check with your local cable system and ask how you can use the Weather Education and Awareness Project materials. If you missed any part of this evening's broadcast, there'll be a taped replay tonight at midnight. So if you haven't got an early wake-up tomorrow or you live on the West Coast, tune in tonight at midnight Eastern Time. Our thanks again to Bob Maddox from NSSL and Captain Bill Melvin of the Airline Pilots Association. And thanks to you, our viewers, for your part in making this program informative. Our next special presentation will be John Hope on hurricanes. You can look forward to that August 21st. And 1 week later, as we mentioned earlier in the program, Global Crisis. Hope to see you then. Good night.
The taped portions of this program were produced in cooperation with the Everyday Weather Project and the National Science Foundation.
The 36-hour forecast. Regional forecast. Special regional information. Stay tuned for the latest weather information here on the Weather Channel.
And we'll take a look now at your Monday regional forecast, and we'll take a look at the Northeast first, and we'll show you the Northeast. Showers will be wide and scattered and far between into sections of the Northeast. Maybe a frontal system will be slowly dropping down, so maybe northern Maine, but sunshine for most of the Northeast. Portland, 59, 68 overnight in New York City. Tomorrow afternoon, 91 in the Big Apple, 91 also at the nation's capital. The southeast will continue to see a lot of sunshine in the southeast, but here comes the showers into the plain states. Also, parts of Florida will see scattered showers and thunderstorms. Overnight, temperatures in the 60s and some 70s in the southern Florida. 88 tomorrow afternoon in Norfolk, Virginia, 85 in New Orleans, 91 in San Antonio. Rain for the plain states, the upper Midwest. Some of it could be heavy thunderstorms at times, so keep an eye on that. 60 overnight in Chicago, 58 in Detroit, 57 in Bismarck. Tomorrow afternoon, 90s at the Twin Cities, ahead of the front, behind it, 75 with still some rain, 89 in Indianapolis. And in parts of the Rocky Mountain region, we'll continue to see scattered showers and thunderstorms from around Great Falls, Montana, down towards Cody, Wyoming, Casper, towards Denver. Could find some heavy showers and thunderstorms, but sunshine for much of the western sections of the country. Overnight, 54 in Salt Lake City, 56 in Denver, 50 in Portland, Oregon, while tomorrow afternoon we'll see temperatures over the century mark in Las Vegas, 103 in Phoenix, 77 in Los Angeles, 83 in Portland, Oregon, 81 in Denver. We'll take a break and we'll take a look at your local forecast.
The current conditions. Regional forecast. The 36-hour forecast. Stay tuned for more weather coverage here on the Weather Channel.